Hello students, good evening, welcome to Yupp Master. Today we are going to discuss about the rules which are going to be obtained when light is entered from rarer medium to denser medium to rarer medium. So what happened? You are going to look into the matter of that light rays are entered from air to water, water to air. What are the observations you have to formulate? The bending of light rays towards the normal sometimes, the bending of light rays moves away from the normal. Simply the refraction is related to bending of light rays. So, it is close to the normal sometimes, it is far away, that is the bending of light ray is moves towards the normal or away from the normal. Why it happened? And you need to discuss why the light rays are not at all deviated if you have been incidented at 90 degrees. So, other than 90 degrees the light rays are refracted. So, the refraction takes place whenever we have been incidented the light rays other than 90 degrees. So, in the case of normal incidence there is no phenomenon of refraction. It is in undeviated position, the light ray does not get deviation. So, please have a look. Yeah, rules for the deviation of the rays in another optical medium. The optical medium is going to be a transparent medium for the light rays and its propagation. Yeah, rule 1. Refractive index is going to be identified mu. It is obtained that ratio of the refractive index of second medium with respect to the first medium is equal to sine of angle of incidence. Yeah, this is also very clear. According to the Snell's law, the ratio of sine of angle of incidence to the angle of refraction, that gives that ratio of refractive indices. Now, if you are going to have a look, refractive index, it does not depend on the angle, it depends on the nature of the medium and its density and temperature. Yeah, you have to take that. Mu depends on the nature of medium and temperature of medium and wavelength and color of the incident light. So, you have to look into the matter. Mu is going to be depending on such parameters related to the nature of the medium, temperature and color and wavelength. Now, you can go for the next one. When the light ray travels from a rarer medium to denser medium, it bends towards the normal at the point of incidence. It is very clear. Now, let us take that when light ray moves from rarer to denser, it is going to be taken as a rarer to denser. Yeah, what happened? Let us see. It bends towards the normal. It has been shown, it is very clear. Yeah, this is the incident light ray. So, the refracted light ray is going to be, yeah, this is the refracted light ray. This is the rarer medium and denser medium. Yes, if you are going to have a look into the matter of the rarer and denser medium, what is the difference? Density, speed of light. In rarer medium, you know very well, the speed of light is maximum as compared to denser medium. So, you can find out that different densities are there from rarer to denser. If you are talking about that, density means the number of atoms per unit volume in rarer medium is less than that of denser medium. If you are going to look into the matter of the denser medium, the number of atoms per unit volume is high. So, whenever you are going to take the different densities, the speed of light is not at all same. The speed of light changes. So, the phenomenon of bending related to the speed of light. The speed of light is less, speed of light is more. That is the indication of bending of light ray, how it is going to bend, how it is going to reduces that. Please have a look if you are going to take this one. When light rays are allowed from rarer to denser, it is going to bend, it is going to bend towards the normal. Suppose if you are going to take that, this is the case. If you are going to take that, this is the case, you can obtain, this is the denser medium, this is the rarer medium, denser to rarer. What happened? If you incident the light rays, they are going, just you will incident the it is moving away from the normal, it is moving away from the normal, this is the normal. Whenever it is allowing to move from denser to rarer, it is moving away from the normal. This is because of the variation of in the densities. Just we have to take that first case and second case. If you are going to look into the matter of first case, rarer to denser, then denser to rarer. In first case, the refracted light ray moves towards the normal, refracted light ray moves away from the normal. So, what can you understood? This is also or this is I. In this case, I, angle of I is greater than angle of R. It is very clear. In this case, the angle I is less than angle R. Your observation is extended to deviation. How you will find out that deviation? Please have a look. If you are going to calculate that angle of deviation also, it may be useful, you are going to get that. Here, the deviation can be estimated by the difference of angle I and angle R. Here also, angle, the difference of the angle of refraction and angle of incidence. Why? The angle of refraction is more, this is going to be more. This is the normal. With this normal, it is moving away from the normal. The refracted ray, this is the refracted ray, this is refracted ray, refracted ray. Yes, this is also refracted ray, this is also refracted ray. In the first case, towards normal, second case, away from the normal. Due to the variation of densities, if you are going to take the different materials, they are not at all having the same densities. Suppose you are allowing the light rays from one medium to another medium other than 90 degrees, it does not get any deviation, it does not get the refraction. What is the reason? The two media, first medium and second medium, both are having the same density, then only there is no refraction. Yeah, due to the variation of the densities only there exists a refraction. So, whenever you are going to take that one medium to another medium, that is denser to rarer, rarer to denser. So, the existing phenomena of bending of light rays towards normal and move away from the normal and without deviation at a normal incidence. Please take that, this is very clear, and undoubtedly you can confirm when light is allowed through a medium of uniform density, it does not deviate. So, the density of the material or density of the transparent medium is uniform, same at all the position, at all the points. If you are going to take that at different parts of that material, the density is going to be same, then there is no bending, there is no refraction of light, that is very clear. So, the density is uniform throughout the material, the incident light rays are not at all going to be deviated, there is no existence of refraction, that is very clear. Now, if you are going to have a look into the matter, thus when a ray of light goes from air into glass as compared to air and glass, it is a denser, it bends towards the normal at the point of incidence. In this case, the angle of refraction is smaller than that of angle of incidence, it is very clear. So, clearly we have discussed why that it is going to have that less angle of refraction. So, next you can take that. If you are going to have a look into the matter, this is a case, light is incidented, light is incidented, this is a normal, this is the point of incidence, this is the point of incidence. So, here a denser medium is the glass, this is the air medium, rarer medium, this is the refracted ray and it bends towards the normal as compared to I and R, angle of incidence is out. So, it bends towards the normal, that is very clear. Now, if you are going to have a look into the matter of that, whenever a light travels from a denser medium to rarer medium, it bends away from the normal. Let us see that. In the diagram itself you are supposed to identify. This is a glass material, the light is allowed to travel from glass to air medium. So, here it is going to move away from the normal, away from the normal, away from the normal, from the normal. Yes, have a look. The incident light ray is going to be refracted, which shows that angle of refraction is more in this case as compared to the angle of incidence. It happened the light rays are moving away from the normal, which may cause us to the bending of light rays is going to be more with respect to the normal, showing that angle of refraction is more in this case. So, angle of refraction I, angle of refraction R is greater than that of angle of incidence. It was observed that very clear. This is the case, we have to identify that. So, R is, angle of R is greater than angle of I. So, angle of refraction is more, right, in this case. Why it is going to move away from the normal? It is very clear, because of the variation of the densities. Now, what we will go for the next case, if light is incidented normally, what happened? In the same case of reflection, whenever light is incidented normally, there is no deviation, So, this is a one case you have to remember. In case of reflection also, whenever you are allowing the light to incident normally on the surface, it does not get the reflection. So, please identify the two cases, reflection and refraction. Whenever you are allowing the light rays to incident on a smooth surface normally at 90 degrees, it remains as unaffected light ray. Yeah, the incident light ray falls perpendicularly on the surface of a glass slab, then there is no bending of the ray of light and it goes straight line path. Yeah, you will find out that angle of incidence and angle of refraction both are going to be 0. Please have a look into that matter. It is going to be incidented normally. Now, you will find out that it is undeviated. This is a undeviated light ray. This is the undeviated light ray with respect to the normal. Simply it traces the path same as incident. It is going to be taking as undeviated path, very simply. Now, you can confirm that the angle of incidence and the angle of refraction is going to be 0. It is very clear. Now, you can go for that. When light travels from one medium to another medium, frequency of light does not change, however, the velocity wavelength of light changes. We have discussed very clearly why the frequency is not going to be changed. It depends purely on the source of the light which generates the light rays. And if you are going to have a look into the matter, wavelength is going to be changed when it enters from rarer to denser or different media, that is of having different densities. So, wavelength of the light is going to change, velocity is also going to be changed. Simply you will remember that, yeah, if you are going to take that velocity v and lambda, they are going to be identified that v is going to be nu lambda, but mu remains same. That is the case we have to confirm, but frequency is going to be same. The reason, the frequency does not depend on the medium, whether the light enters from rarer to denser or denser to rarer. If you are going to talk about that frequency, yeah, light is incidented in the form of wave. This is the incident ray. Yeah, this is the incidented, it is going to be I and R. This is the light ray, whatever we are going to get that. This is the refracted, this is the refracted light. This is the incident light. Yeah, incident light and refracted light. Now, if you are going to have a look into the matter, frequency means the number of oscillations made in 1 second. Here the number of oscillations remains same, nu. Suppose let us take the number of oscillations are going to be 1000 per 1 second. Here also same, the number of oscillations made in 1 second is going to be 1000, but might be having the difference in wavelength, velocity. Now, if you are going to look into the matter of the frequency, the number of cycles made per 1 second in case of the incidented light ray and refracted light ray is same. So, that mu is going to be same, mu dash. Let us assume it is mu dash, mu is equal to mu dash, that is number of cycles made per 1 seconds, n by t. Here also n by t, both are same in this case. So, they are going to be equal. It does not. If you want to change that frequency, you have to change the source properties. Like that, if you are going to change the energy of the source, let us take that a light, a bulb. If you want to change that frequency, you have to look into the matter of the source of the light, then only it is possible to change the frequency of the light. While we are talking about energy, the refracted light, some part of energy in case of refracted light is going to be less. Some portion of the energy of the incident light has been absorbed by the medium, that is very clear. So, that we can decide the wavelength changes. Due to the wavelength, due to the change, velocity is also changes. So, that it is very clear the frequency of light does not changes, no doubt at all. Now, you will take that second point. When a light ray passes from rarer to denser, the angle of deviation, if we are going to get that, it is going to bends towards that. So, we will take that angle of deviation, that is of I is d is equal to I minus r, how it is going to be deviated. It depends on the medium and density. Now, it is also there, whenever it is allowed to enter from denser to rarer, it is going to be taking as a r and I. You have to take that r and I. Yeah, it is going to be taking that. You will find out that here angle r is going to be greater than angle I. Here, yeah, it is going to identify that. You have to take that. Yes, you can confirm here also. You will confirm denser to rarer. Yeah. According to the phenomenon of refraction, whenever light travels from denser to rarer medium, you are going to identify that bending is towards the normal, away from the normal. Please take the question. When a ray of light travels from a rarer medium to denser medium, it bends at the point of incidence. Yeah, that is towards the normal, away from the normal, please take that, and undeviated, and we cannot predict. First one, you have to look into the case whenever the light is allowed to pass from one medium to another medium. Now, you have to look towards the normal or away from the normal, but when light is allowed to pass from rarer to denser, it is going to shows that angle of refraction is small, that it is going to bend towards the normal. It is going to bend towards the normal. If you are going to take that, this is the normal. If you are going to take that, the refracted ray moves towards the normal. The refracted ray moves towards the normal. That is, it is going to move from here. So, it is going to move means it shows that angle of refraction is less. So, here in this case, angle I is greater than angle R. So, angle of incidence is more, like that you will confirm. Yeah, this is I. Yeah, a light ray travels from a rarer medium to a denser medium. It bends at the point of incidence. It bends at the point of incidence towards the normal. This is the correct answer. This is very clear. Now, you have to take another problem. What happens when it is allowed to travel from denser to rarer? According to the phenomena of refraction, whenever a light ray travels from denser medium to rarer medium, yeah, it bends. Now, ray of light travels from denser medium to rarer medium. It bends dash at the point of incidence towards the normal or away from the normal or undeviated, or we cannot predict. So, 100% we are going to confirm the angle of refraction is going to be more. The refracted ray moves away from the normal. The refracted ray moves away from the normal. The refracted ray, it moves away from the normal, moves away from the normal. So, it is very clear if you are going to take that. This is the angle of incidence. Let us assume I and R. So, you have been confirmed that it is going to be away from the normal and deviated. It is going to be deviated, showing that refraction. So, this is the correct answer. Yeah, we cannot predict that. Right. Now, you can go for another third possibility and frame down that if the incident ray falls normally or perpendicularly on the transparent surface of glass slab, it travels towards the normal. So, please remember, if you are going to have a look into the matter of that normal incidence, there is no case of bending, no case of refraction, so that it remains as undeviated light ray. Please have a look. It remains as undeviated. This is the correct. Yes. So, please have a look into that matter, which has been incidented normally or perpendicularly on the surface of a glass slab. It travels in the same path, but it does not shows that deviation. There is no angle of refraction, so that it is known as undeviated light ray. Now, that is very clear. Let us move on to another problems and refractive index of a medium. If you are going to take that refractive index of a medium, simply you will find out that mu is equal to C by V. It is the ratio of the two speeds. What can you talk about that? Ratio of two speeds. in different media. Different media. You have to find out that. So, refractive index, it does not have the units, simply it gives a significance of two velocities or speeds in the vacuum and in the medium. So, this is going to be taking that speed of light in vacuum, and this goes that speed of light in a medium. Yeah, that is very clear, you have to get this one. So, it does not have the units because of the ratio of the two parameters, two same parameters. Now, if you are going to talk about that significance of the refractive index, now if you want to identify that change of speed of light when it enters from one medium to another medium, that change, it can be identified that how many times that speed of light changes. Yeah, if you are going to take that V is equal to 1 by mu into C. Yeah, simply 1 by mu times speed of light in vacuum. Yes. So, you can confirm that this is the matter. If you are going to know about that speed of light in a medium, it is going to be reduced 1 by mu times. It is very simple observation. When the light is allowed to move from rarer to denser medium, its speed is going to be decreasing gradually by increasing its mu value. So, mu value, it gives the significance how the speed is going to be affected when the light ray is traveling from one medium to another medium. So, the speed of light changes 1 by mu times that of speed of light, where mu is the refractive index of medium, where mu is the refractive index of medium. Mu is the refractive index of medium. Yes. If you are going to have a look into that medium, it is known by some value. Suppose, you know, in case of the glass material, yeah, you can take that air glass interface, you know, speed of light in glass is equal to, yeah, it's going to be 2 into 10 to the power of 8 meter per second. How it is obtained? That is equal to C by mu. That is, if you are going to take that glass, its mu value is going to be 1.5, that is 3 into 10 power 8 meter per second divided by 1.5. So, easily you will find out that 2 times, it is very clear. So, the significance of the refractive index is highlighted to know about that speed of light in a particular medium. If you are going to take that for glass, air, now you will know that mu value is identified, that mu air it is 1, mu glass it is 1.5, mu water that is 1.33, that is mu quartz is equal to 1.52, mu diamond is going to be 2.52. So, these are all the different values, how that it is going to give the significance of speed of light. Simply you will find out that speed of light is going to be 1 by mu times. This is the significance of the refractive index of a medium. So, you have that comparison by knowing that refractive index. That comparison is limited to speed of light in that particular medium. Right, let us go for another one. Please have a look. Yeah, absolute refractive index, it is also identified that velocity of the light in vacuum and light in medium, it is identified that the transparent medium, the ratio of the speed of light in vacuum to the speed of light in the medium. It is very clear what we have discussed in the previously. Now, let us go for that. It does not have that unit ratio of the two speeds for a given transparent. So, ratio of the two speeds, that is nothing but mu is equal to C by V. For a given transparent medium, the value of mu is always constant, that is very, very important. For a given medium, glass, mu is always constant, mu is always constant. Yes, how you will predict that? Suppose if you incident the light rays at different angles, the mu is going to be identified with respect to the angle of refraction. So, it is going to be taken that experimental study. If you incident the light rays at different angles in case of the glass material, you will get that the refractive index is the same. Yeah, suppose you have taken that glass material. So, that is sin theta I by sin theta r is equal to mu, that is it remains constant. Yes, you know theta I carries different values if you incident. Let us see the possibilities. If you are incidented the light rays, yeah, you will incident the light rays. If you can take that, you will incident. This is I and R. This is also I and R. In the two cases also, this is air, glass. So, if you incident that at different angle for that material, you have to take that ratio of the two angle of incidence and angle of refraction, it becomes same. So, you will get the same value of mu. So, that indicates that for a given transparent medium, the value of mu is always constant and indicates, yeah, it is same for the glass, it is same for the water. For a one particular transparent medium, the refractive index, its refractive index is same. you can calculate by taking a different angle of incidence, first case and second case, and practically you will get that same value of mu. What is mu? Is the refractive index of glass. Mu is constant, that is very clear. Now, how many times the speed of light is more than that of speed of light in a medium? So, if you are going to take that, mu is equal to C by V. If you are going to take that for a glass material, mu G is equal to 3 by 2. 3 by 2 is equal to C by V. If you are going to take that V, yeah, this is in vacuum, it is in medium, that is nothing but glass. So, how many times it increases or decreases, it is going to be conveyed. If you are going to take that for a speed of light in a medium, it is more. In case of rarer, it is more. Now, it is very clear, this point has been discussed in this way, you have to show that. So, the refractive index of glass is 3 by 2, that is nothing but 1.5, but it is going to change 2 by 3 times, nothing but decreases. So, if you know the comparison by means of refractive index of a material, it is very clear. Now, if you are going to have a look, V in the glass is going to be reduced 2 by 3 times of that speed of light. Now, it is very clear if you are going to look into that matter. Yes, example they have given, already we have discussed that examples like glass air interface. Yeah, that is very clear. Mu glass is equal to 3 by 2 times of that, it is going to be getting that C by V. If you are going to look into that matter, easily you will find out that 1.5 mu G is equal to 1.5. This is the option what we are going to take. So, speed of light in vacuum, it is going to be 3 into 10 power 8. Speed of light in a particular medium, that is in glass. If you know the speed of light in the glass material, then easily you will find out that refractive index. Taking the ratio, it is going to be cancelled out, 1.5. So, how you will calculate that refractive index of a particular transparent medium? If you know the speed of light in that medium, then only you can calculate. Already you know that speed of light in vacuum. So, it is going to be taking that ratio, easily you will find out that. Please have a look. Right. Critical angle. So, we are about to know that whenever light enters from denser to rarer, if you incident the angle, the angle of refraction, it becomes 90 degrees with respect to normal. That is a critical angle. You know, this is the case we have to confirm. Yes, rarer medium and denser medium, I is equal to IC. This is the angle of incidence. angle of incidence. What can you say about the critical angle? Critical angle is the angle of incidence at which that angle of refraction becomes 90 degrees. Right, this is very clear. This is the refracted ray, refracted. This is the critical angle. So, you will confirm that I is equal to IC. At I is equal to IC, you will get that R is 90 degrees. So, in the given problems also, the refractive index is related to critical angle, that is sin C is equal to 1 by mu. That is very, very important. So, we have obtained this relation by applying the Snell's law only. Very simple, you can confirm that, that is mu 1 sin I is equal to mu 2 sin R. So, if theta c is identified, you can get that. It is very clear. We are about to know the problems in the previous classes also, which are going to be discussed, change of wavelength, change of and velocity and all these things. Like that, if you are going to frame the problems by knowing the relations in refractive index and critical angle. So, in the next classes, we would like to discuss more. Keep watching these lectures. Thank you.